Economy built into this for time delays that will happen as you move further and further out. So there's a lot to think about. And like we said, a lot of this can be studied on the space station.
The delays are something that I think a lot of people haven't quite gotten their minds around yet, because for long duration, we're talking about a delay in one-way communication that could be 20, 30 minutes long.
Right. So operations need to happen, I think, a little bit differently, so that needs to be thought about and considered.
From the personal point of view, the personal physical point of view, there are effects from being in that environment that we have to learn how to deal with. Can you give me 2 or 3 examples of specific experiments that you're going to be a part of, that you're going to be one of the guinea pigs for during this trip to the station?
Absolutely. One of the hot topics right now that I'm sure a lot of people have heard about is ocular health. We've discovered that there are quite a few astronauts coming home with decay in their eyesight. And it's not known exactly at this time what causes this, but it's an important thing, especially if we're going to be spending longer and longer times. Will it get worse as the time goes on? And so they're really starting to do a lot of experiments with us, taking images of the retina, taking pressures, looking at your, getting eyesight checks throughout the mission. And we don't know quite, we were just starting this, doing all of these tests. We haven't done them on a lot of astronauts yet. And so I would like to think that once we get all these up and running, that there will be earthbound eye diseases that we could contribute to the success of solving some of these. And so I'm confident there will be some type of a Earth application that will come from this. Another great one to talk about is bone density. With the lack of gravity, our bodies are pretty smart, and we don't have, there's no reason for our bones to be here because we don't have to be held up against gravity, and so they start to degrade, and they degrade very, very quickly, and in fact, even faster than a 70-year-old woman with osteoporosis, probably about 10 times as fast. And so we have a great opportunity to look at the decay of the bones and figure out what type of processes we need to mitigate these decays. And there's great potential for using that and applying it to earthbound osteoporosis.
The cardiovascular health is another of these areas that in a similar way, right?
Absolutely.
Those are some of the experiments you're going to be working on. Do you know how many different experiments you're going to have?
Well, including not just the health experiments, but including all of them, there's somewhere around 150, and that includes, gosh, up to 400 investigators from around the world. So there's a lot going on.
And you're an expert on all of them?
Absolutely. Absolutely not.
Now, there are a lot of other experiments in other scientific disciplines that are in these laboratories that you brought up, in special equipment that was made just for the purpose. Give us a handful of examples of some of the other types of the science experiments that you're going to work on. And tell me how those things are going to impact future exploration, as well as have some effect for those of us who don't ever get to leave the planet.
Sure. Like we had mentioned before, the main aspect of the space station that is wonderful is the fact that we don't have the gravity to affect what we're doing. And a lot of the processes that take place on Earth, as in fires, combustions of materials, solidification of materials, flow of liquids, all of that is highly affected by the force of gravity. And scientists, when they want to understand how all of these processes take place, really need to look in the intricacies of it. And that force of gravity is so strong with all of this that when you can get rid of that, they can study how these processes take place and write their mathematical equations and understand the little pieces, so they can come up with designs for more efficient flow of fluid, where pumps maybe don't need as much energy to force the fluid to flow, or where we can get more powerful semiconductor materials, or we can burn flames without the off-gassing, the harmful off-gassing. So there are a lot of, in general, of those processes where the benefit of doing it on the space station where there's no gravity is priceless, really.
There are experiments into how plants grow differently in microgravity too, right?
Yep.
There are other things like that.
Absolutely.
With all of that science to work on, you still have the responsibility, you and your crewmates, of taking care of the whole space station, taking care of the laboratory that you're working in as well as the vehicle that is housing it all. Can you give us a sense of what it's like? What other kinds of things do you have to do? What's a day in space like for a space station crew member?
You're right. We're basically maintaining our house, our spaceship, our laboratory. A lot of it is the very mundane, changing filters, vacuuming, cleaning. Every so often we have to change out equipment. And a lot of it is preventive maintenance. We want to make sure that things do not break down, so we're going to take care of them as we go. Sometimes something breaks and we need to replace it. So there is a lot of that through the week and through the 40-hour week that we're working. Actually, probably a little more than that, but we'll call it a 40-hour week. So just like you're maintaining your house or your car at home, there's a lot that has to be done, and then we do as much of the science when we can.
You get some time off, though, too, don't you?
Yes. Weekends mostly off, although I hear the house cleaning happens on the weekends, but that happens at home, too. So.
Yeah, but you get an opportunity to just enjoy being there.
Yes, yes, and that's one of the things I'm looking forward to a lot.
And after all of that work that you do inside the station, from time to time, crew members have to go outside the station to do some work. Now, there's a plan that could change, but what is the plan for spacewalks during your time on orbit? Who's going outside, and what are you going to do as a member of that team?
We have quite a few EVAs planned, actually. A few on the Russian segment, where it'll be exclusively Russian crew members going out the door. For the U.S. segment, we have 2 on the books right now. The EV crew members will be Chris Cassidy and Luca Parmitano, and I will be staying inside, and one of my jobs will be to get them suited up, get them out the door, get the airlock depressed, and make sure they're good to go. In one of the EVAs, I'll be doing some robotics tasks inside, and then my job at the end of the EVA will be to get them back in and make sure all the equipment is in the order that it needs to be when the EVA is done.
Robotics work is something that you've already got the experience at. Which of the arms are you going to be running this time?
This will be the SSRMS, the big arm.
The big arm.
Yes.
Because you've run the Japanese arm before, as well as the shuttle arm.
That's right.
So it was a very busy mission.
Yes.
There are no shuttles coming to the station, but there are supplies headed up there on an increasingly regular basis these days, coming in a little fleet of supply ships that are provided by various members of the Space Station Partnership. Tell us, give me the short version of who all these ships are and how they're the same and different. What do they, what kinds of opportunities do they provide to deliver supplies to the station?
That's right. We have quite a few vehicles coming up. We have the standard Progress vehicles, which come at a pretty a rate that pretty much stays the same. That's the Russian vehicle, that cargo ship, and they dock to the Russian segment and bring up a lot of equipment and supplies for us. We also will be having an ATV. It's a European transfer vehicle, automated transfer vehicle, and that docks automatically to the aft end of the station after the service module, and that should be coming in June, according to the plan. We also have an HTV, which is the Japanese, their vehicle, and that one we actually grab with the robotic arm as it comes in, and we use the robotic arm to attach it to the space station. And we're also hoping that in the period of time that we're there, we'll get the vehicle from the Orbital Sciences Corporation, the Cygnus vehicle. It will be, potentially we will get their first demonstration flight. And so that would be very exciting to see them make it to the space station for the first time.
And that is similar to the HTV.
That's
in that
right.
It's grappled by the arm, right?
Exactly. Yep.
And when we grapple that, will that we be you?
It's hard to say yet.
Oh.
I guess it depends on if it comes before or after HTV and who goes first. But potentially, I'll be either on the arm for the HTV or the Cygnus.
You've trained for it.
Absolutely.
In any case, is that kind of arm operation significantly different than what you did before?
It is, in that we're trained. It's very dynamic, and the vehicle could be moving as we're coming to, they try to design it so it's very steady, and in fact they all have been very steady to this point. But we are trained that if there are rates on the vehicle, we need to be able to fly the arm at those rates to grab it. So it's a little bit, the training has been more challenging in that respect. But we hope, like I said, that the vehicles are stable and that we won't have to use that training.
Can you say what it is about all that you have in front of you there that you're most looking forward to about doing when you get to the station?
There's so much. I'm looking forward to doing all of that, the science part of it, the robotics part of it. You know, the living there, I think I'm probably looking forward to the most, just making that my home, and I think that's going to be pretty special.
Karen, what is it that we are learning from these missions to the International Space Station that is getting us prepared to push human exploration way beyond where we're going right now?
I think probably the biggest thing in my mind is the human physical sciences and our health and how we counteract the negatives like we talked about before. In my mind, that's one of the biggest things. And then of course the hardware issues and how we get the equipment to work the most efficiently without needing repairs, a lot of repairs. And we're learning all of that as we're going through this process.